we continue SIP tester training, session number 3, and we talk about architecture of SIP tester.
Okay.
The SIP tester, most customers use it as a Windows desktop exe file with Windows GUI. It's here, so it runs on Windows XP, and on Windows 7, Windows 8, Windows 10, and on the Windows Server operating systems too. And the difference between operating systems is in maximum load capacity. Windows 7 has bad performance for about 1000 G.107 calls. It will not be possible to run it over Windows 7, but on Windows 8 it was possible, and the Windows Server operating systems they work good, and it also depends on network drivers. There is also SIP tester command line interface. It is here, CLI file. So no, just CLI. It is. Do you know what is command line in Windows? Yeah, so it is possible to create bad files and to run tester from some unit test system. There are many parameters for command line described in tutorial.
It's online, right? In the website.
In command line, you specify XML file to execute script, log level. It runs the test and returns results. And here is example. It's clear, right?
Yes. Ready.
Command line. Unit test. This is internal thing. Not for customers, and there is also Windows Service mode. Windows Service, when a customer doesn't need a user interface, he can install SIP tester as a service. Here's a bad file to install SIP tester as a service, and it will run in Windows Service. It is not installed here, so it will run in the background without user interface, like a switch. It will automatically start with Windows. Like this service, there will be a SIP tester service, and in Windows Service mode, SIP tester has a web user interface, web UI.
Like if we run it as a service, this is the interface.
It is available also when SIP tester runs in GUI mode. When you need to access SIP tester remotely over HTTP from mobile device, for example, to start test, stop test, see the results remotely, you can do it. I set up password. SIP tester. outgoing calls. We see the script. Here there is no user interface. GUI for scripts, only XML mode.
Okay.
And we can stop call generator here, and we see that it is really stopped in GUI. They are synchronous. Start.
Okay.
And we see that it is started.
Yeah.
Okay.
So the good point is that it can be accessed from anywhere, right?
Yes, but to access, you need to open the port in firewall. This 90.
Oh, okay, yeah. Yeah, to access it, open the port, just like the soft switch.
Yes. Open the TCP port.
Okay.
And
Okay.
better open this port only to selected IP addresses.
Okay.
Okay. Now, what's next? What we have in SIP Tester? We have call generator and outgoing calls. It has maximum channels settings and interval between calls, and also number of calls to create in bursts at one time. So if we set it to, for example, 5, it will create calls in batches of 5 calls. Some customers need to test in this way to make overload. When all 5 calls are generated at a very short time, at the same time. This is about burst mode. Limit total number of attempted calls is used sometimes. When customer wants to create exactly 1,000 calls, total calls, he enters this. This is the limit for the test.
Okay.
Okay, what's next? SIP scheduler. There is also schedule. Start timer on schedule. You select when to start.
Yeah.
Tomorrow or every day at start calls at this time and stop at that time.
Okay.
Some hour and minute. Schedule. Next. SIP trace. SIP trace. It means that we have access to SIP trace in CDR. When we click CRC. And also we can access it from web interface.
Okay.
CDR here.
In detail? Oh, okay, secret, yeah. Just like the soft switch, has
soft switch, yes.
Yeah.
This is CDR. The SIP trace is these packets are stored in memory, and the memory is CDR memory is limited. Keep 2,000 calls in memory.
The latest 2,000 calls, right?
And old calls. Old calls are erased from memory to avoid memory leak. If I keep all these files in memory, it's not good. The server will be overloaded.
Yeah.
So
definitely.
2,000 recent calls, we can check SIP trace.
Okay.
SIP trace is can be also available from PCAP file, and it needs additional settings. PCAP packets are not saved to memory. It must be configured in settings.
Okay.
Configure it in PCAP
Okay.
access here. Save SIP
Okay.
packets to memory. RTP.
RTP
And
packets.
also say first it saves to memory, and after that it can save the packets to disk.
Okay. So if the packets are saved into disk, is it going to cause the overload too?
We can remove saving from memory and just have them
Saved to disk, right?
And
okay.
It will free the memory.
Yeah.
When the call is completed.
Yeah.
Okay. Save to disk. Let's see what it means saving PCAP to disk. PCAP. I will decrease call duration to make it to make the calls complete faster, and I abort all current calls.
Okay.
Now it creates new calls with short duration, and in settings there is setting PCAP. Search by PCAP. Save to disk and path pattern. There is a path pattern setting which has default value PCAP /
okay.
and it is a subfolder in SIP Tester.
Yeah.
We see
PCAP right there. Yeah.
it created this folder PCAP. So when something doesn't work, when you create call and it gets rejected by server, the SIP trace and PCAP are it is evidence to provide to vendor that it doesn't work.
Okay.
You send the SIP and RTP to provider, and you tell them that the call failed. Here's the SIP trace. Here's PCAP.
Yeah.
I open SIP.
It will open in Wireshark, right? Always.
In Wireshark, and we see the packet SIP 200. Okay. This is successfully completed call.
Yeah.
Okay, it's about SIP trace. Next, settings. SIP Tester has global settings. So with descriptions, and you can search by text. Just. And there are many settings. Some of settings are they have GUI in the top.
Okay.
For email or PCAP, we just changed them. Okay, I'll turn off saving PCAP, not to overload
the server. Yeah.
Disk.
Oh, okay. The disk will overload.
Disk. Settings for sending email. Okay. You can save settings some file, or just copy the settings XML file to another server, for example.
Yeah. To have the same settings, right?
And restore them later.
Yeah.
Import from.
Okay.
Okay, and by default, SIP Tester creates a backup version of settings per hour.
Okay, so it gets saved automatically?
Yes, it gets saved automatically every time you change the settings. So, for example, you play with these settings and you see that something stopped to work, and then you click Show Backups, go back to some day and hour of day.
Just restore the settings, right?
And restore settings, copy
it's really nice
this
option.
file and restore into main StarTrinity settings file. Override. When you restore the XML file, you have to close SIP Tester.
And restart it, right?
And start again with old settings. Okay. Settings. Incoming and outgoing scripts. Okay. For incoming scripts, there is GUI and there is also XML. GUI edits XML and doesn't have all rich features of the XML.
XML is more detailed,
It has many elements. It is our own language in developing StarTrinity, especially for tests, for any call processing.
Yes.
It has documentation and examples. So elements in CallXML for incoming calls processing, they are processed one by one. First it goes to wait, then it goes to this block, then to accept, and it can go inside the block. And what it does for every element depends on every particular element, and we have explanation on the website. So wait, for example, wait, search by wait, wait, introduces a delay with specified amount of time. And the value is set in script. So this is straightforward, I think.
The script value random 2000 milliseconds, 2 seconds.
This syntax is called substitution. The rand is substituted by a random value. Substitutions are described here. Rand x is replaced by a random integer value. Okay, with mean average value of x. Okay, wait. After that, block. Go to block. Groups elements into single block. And it has probability of executing nested CallXML elements. This is what is used in this case. So with probability 50%, it rejects calls. Rejects with value
busy, right? 486.
484. Rejects. Okay. There are many examples, but users always ask for more and more examples, and also some new elements they don't have good examples. So, well, when I have time, I write examples.
Okay, examples is clear to understand, like all the elements.
Yes. Accept means connect.
Answer. Yeah, connected.
Answer. Send 200 OK. SIP. And play audio for some time. And after that, disconnect. This is connected time.
Yeah, 20 seconds.
Yeah, this is duration. Total 20 seconds. This is XML. Basic XML, please. And we can modify it right here. Just, for example, accept and play audio. No rejection.
So there is no wait time rejection. All the calls will be connected, right? 100%.
Connected immediately. Or we can put reject. You see, when XML is not valid, it displays an error. That name cannot means that I didn't close the tag.
Oh, okay.
Reject value equals 503, for example. This script will reject all calls immediately. And before rejection, we can wait, for example. Wait value equals 1 second. Okay. And same thing for outgoing calls. Here is GUI and XML.
Hello?
Okay. You hear?
Yeah, I can hear.
It generates calls to this server, to this SIP port, and this number. We can change the number, for example, and it is applied immediately. No need to click the save button.
Okay.
And we see results immediately. It already generated these calls to 7777.
Okay, yeah.
And caller ID, for example, immediately it generates.
It changed, yeah.
Okay, and it's available also in web configuration, in incoming calls, outgoing calls. Okay, like this. Is it clear about general XML?
Yeah, definitely, yeah.
Okay, good.
And it's easy to access the online contents. So get the explanation, it's easier to use.
You mean this link? So
Yeah. Okay, yeah, documentation.
You can click here. Yeah.
Okay.
The documentation. Oh, I didn't talk about default variables. When the caller in XML, you can access some variables. For example, I'll show here. When the call is answered, let's access call answer delay and display it in CallXML log. The log is available in here in bottom. Answer delay. We put element log value equals and I put empty log, and it displays empty text.
Okay.
Log value equals answer delay equals, and I put the placeholder for variable answer delay, and in milliseconds immediately it displays this answer delay, And
Okay. Yeah.
this is the logging is necessary when you write a new script. You need to see what happens in the script. Here you can write call is answer delay equals something.
Okay. Yeah.
And also it is available in web interface status CallXML log.
Okay.
Always answer. Refresh.
And you can change the XML from here too, right?
Yes. Here in outgoing call is answered. Call is answered. And 2. Call is answered 2. And we see here call is answered 2, and it is applied. There is a system error log. What it displays? It displays errors. There was an error in XML, unmatched dollar character. While I was typing this script, if I make a mistake here,
it will show
I
here.
just put this semicolon. It writes an error, and the error log is accessible in web interface too. Exception in log, unmatched dollar character, and we see in details of an error that the line.
Yeah, which line is the error? Yeah. Okay.
And from this line, we see that the error is in XML, and we go and fix it in incoming, outgoing XML. We put semicolon back, save. Okay. This is back here, and no more errors. We can clear, and it works again. Works again. Okay. One more default variable. For example, SDP attribute SIP header. SIP header. I want to display the SIP header that is received from destination. So what I do to remove a line temporarily, you can comment in XML comments. Okay, no more logging. I turn it off. Clear. And I just use copy and paste, and I use the SIP header via header. I will display. You should know what is via header and what it means from PRTP. If you want to know.
Okay.
It's a SIP standard. Okay, via header receive in 200. Okay, is SIP header.
Oh, okay.
Immediately it displays via header, and we see that in 200. Okay, here is via header. It shows
via.
If you need to process this header in some way, or if you want to write it to CDR file, you can use it. Okay. For example, supported. Let's for example write one more header. Or no, let me server. like a version of server. SIP
Mm-hmm.
header, SIP header, server.
Server? Yeah.
Yes, server. Server header received into okay. Log server header. Okay, you see?
Yeah, StarTrinity server. Yeah.
Immediately it displays it in log.
Mm-hmm.
And what I will show you how to save it into CDR. CDR
Okay.
is it could be saved to CSV file, the CDR, and we can add a custom header, custom CDR header using an XML element, write CDR. Okay, I think in next sessions we should go through these elements. There are many interesting things. It is extensible language, and it is very it's not very, but it's very fast for me to extend this language. And if I create a new element in this language, it doesn't mean that all users use new elements. Okay. What do? We write it to log. Write CDR. Save a variable to CDR report. And here is example. Here is example.
Okay.
I stop calls. I don't want to make changes on live traffic, because I don't want to have CDRs with this header. And first I change it. I don't want to corrupt my CDR files. I make changes. Let be server header, server SIP header, and I write value from variable start SIP server header. It should be displayed now in CDR. Okay, we see that it appears in CDR, this SIP header.
I think after the calls are completed, then it shows the header, right?
Yeah, it shows only for completed calls. When the call is written to CDR, and CDR files are here. CDR files. It should be here. it is here in CSV with SIP header field. Okay.
Yeah.
Okay. Good. Good. Well, script. Next, log. There is system error log and CallXML log needed for debugging. I already explained.
Yeah.
Summary reports are report statistics. This screen, current calls. You can click and here's a chart of number of concurrent calls over time. Is history. It was 50, and then I reduced it to 12 concurrent calls. And these are times when I stopped the test. It's easy to track, and it is also available in web interface. Web interface. Status. Yeah. Current calls. Here, concurrent calls. I click same chart in HTML.
Yeah.
There are also charts for these measurements. Calls loss packet. Okay, we see for our network test that there was some packet loss.
Yeah.
And from the chart we can see at what time there was a peak.
Yes.
At what time? Sometime before 10 a.m. there was a peak packet loss. Also with in web interface and in this screen. Okay, here 9:50. You see the time of peak. What this screen is important. Current connected calls. Not all calls at a single time are connected. Answered. Now we configure the server to answer calls immediately, and if we go to server, and we can add some delay. Accept. Here it accepts immediately. We can add wait value equals, for example, 6 seconds wait before connection the server, and we'll see that current calls
increases
32, but connected answered calls not 32.
Answered call is rest, yeah, because it is having delays.
Sorry?
It is having wait time, right, before it answers.
Yes, and that's why at every single time not all calls are connected because of that delay. Recent calls per second. It is what we said in call generation settings. 300. It means 3.31 calls per second. We can control it.
Okay.
If we reduce number of calls per second, it will drop. Sorry, it drops now. It is average value. It drops. Next, receive. This server doesn't receive calls. It is call generator, and on
the France side, yeah. Netherlands.
On-caller receiver in Netherlands we see
It should be receiver, right?
We see received calls. Number of received calls per second, total average received calls per second. Okay. Attempted outgoing calls. Number of ASR report is here. ASR and some calls failed. 179 calls failed. We should be able to see it in CDR. What calls have failed? Connection status is not 2000.
These all connected call.
I don't see. I don't know which calls failed. Well, report statistics. Answer duration. This is ACD.
ACD.
Duration. It is chart. Minimum average. This is average. 9.5 seconds. It means ACD.
Okay.
ACD for entire test. When we need to reset the statistics, there's a button.
Reset counters.
Counters to start a new test. Start a new statistics. Okay. I reset and it becomes 0. And we have a new average duration again.
Okay.
ASR 100%. ACD 3.4. That's because of duration of music. It is exactly what we said in script. If we increase it to 8, for example, 8 seconds, it should start to increase. I wait until completed call. Okay. Now it is.
There's increasing.
8 seconds. Immediately.
Changing.
Calls. Registers. This test doesn't send any registers. Remote server. This is needed. When you test Cisco gateway, when you test some soft switch, you see its version. Usually, this header contains version of tested software. Like that. You can open this window in there's not enough place, and you can open. And these windows are synchronous. Main window and this child separate window. You can see it full screen. Okay, next. Measurement started at what time? When we reset the statistics, it was 2 minutes ago. Duration, 2 minutes ago. SIP call quality. Indicators. These are aggregated CDR fields and measurements. Callers, I talked about caller and calls RTP streams in previous sessions. MOS score, it is this MOS score G.107. It is calculated based on jitter, on network jitter and loss, not on actual audio quality.
Okay.
And it's not a very good indicator when the network I need to write a diagram. So what it means, G.107 MOS, caller calls server and makes SIP calls, and it receives RTP back. It's called RTP field calls and MOS G.107 MOS is function of packet loss and jitter at caller network card. And it is helpful when bad quality is caused by the network. So, for example, here loss occurs, loss in internet connection. Then we will see bad jitter, but it's not always like that. There could be no loss in internet, but when the cold side is connected to another provider and loss happens here, what it means that bad quality will happen after provider, and we don't have access to the provider. For example, you purchase some VoIP route, and you make calls to the provider's IP, and you see that network between you and provider is excellent, but you hear you have complaints from customers. They hear bad quality because loss happens after the provider. And the G.107 will not work in this case. That's why it's a good indicator when you clearly understand that losses are when reason of losses is in internet between you and provider, and you test this internet. And for another kind of loss, there is another test with audio verification, and we'll describe later. Then, when the content of audio is verified, not just RTP jitter and packet loss, there is another test when caller calls some kind of like a provider, and there could be anything, and it will go to DID provider, and it will go to SIP tester again, and it will play echo. This is two-way audio verification. Play echo, and the caller will check full-way audio path, and it will verify the audio and quality of audio. And it's a different test. It needs custom CallXML. It is CallXML verify audio. It's a very important part of SIP Tester, audio verification. Okay, what's next here? 100 delay. 100 response in SIP is sent immediately after the when SIP server receives invite, it immediately responds with 100 trying. You see, even if there is a delay before answer 6 seconds, but 100 trying is sent immediately in the SIP protocol. And if it is not sent, it means that there is something wrong in internet, or the remote server is overloaded. And this is also a major indicator of a test. And it's good here. 100 response delay. Good. I think below, it depends, but usually below 1 second is good. Well, the average should be low, but in peaks it could be 1 second or 500 milliseconds. Answer delay is delay between invite and 200 OK. It is what we set in the script. 6 second delay. That's good.
So exactly 6 seconds, right?
This is delay. What? Is the PRTP delay? The delay between session establishment and between actual RTP, and it was bad for some call in the beginning of test. Now it's good. What it means when this delay is bad, it means that the call is established, signaling is established, but there is no media. Person hears nothing, silence for some time after connection. It indicates the such cases, and we can track the call with such bad delay, and we can see call ID using CDR. Okay, next. This is signal. This is an important thing. This is signal delay. Audio signal delay. Okay, I'll demonstrate this. What it means. It means delay between invite and between receiving a non-silent audio packet from destination. And this field uses audio signal. It decodes audio signal and saves it to CDR and statistics. Let's do this. On this server, we will remove this delay and put it after connection. 6 seconds before playing music, and it should be about 6 seconds. Let's better do this. 3 seconds before connection, 6 seconds after connection, and then music. And at this time there will be silence. Okay. I reset statistics. I clear CDR, and I see. I display the fields audio signal delay. I don't see it now. Audio signal delay.
I don't see it either.
Audio signal delay is here.
Okay.
Signal delay.
Yeah.
The minus 24 decibel. It is configured in settings as threshold of loudness. What is considered as silent and what is considered as signal? Audio. Here's a configuration. Minus 24 decibel. Default signal detector threshold in decibels. Okay, this setting. Minus 24, it's a good value. Okay, audio signal delay. Do you see it is about 9-10 seconds for the new call? You see the measurement?
Yeah.
Okay, in the report we also see that it is 9 maximum 11.7 seconds. Now on the destination server we simulate a kind of delay. We set it to 16 seconds.
Okay.
So it means 10 more seconds of silence. And what we see on the caller side, we need to make sure that it listens for 16, let it be 20 seconds. It will listen for 20 seconds after connection. 20 seconds. And we'll see what happens in CDR. You see it is 19 seconds. So this helps to diagnose problems with no signal at all. When you make calls to, for example, call center, and the call center must play IVR always immediately. And this test reflects a problem with audio, with media server. Okay, and if we remove the play audio at all from the server, what happens? We remove audio. It's like crash of it means crash of media server and playing only silence caller side. You understand?
Yeah.
Okay. And we will observe CDR. And see, these are still old calls. It must be empty. You see, it's empty. Answer duration is 20 seconds, but no audio signal. What is helpful? So the person tester sees no audio. What do we do here? We can look into PCAP. Wireshark displays audio for G.711, and we can record audio in SIP Tester in settings. Record RX audio streams. We check this. See, this is recording. It records in a call. There are two streams: transmitted RTP and received RTP. The RX means received RTP from destination to this SIP tester, and the recorded WAV file. Where do we see it? Recording. RX recording. We display it as a field. Okay, you see it in CDR. Listen and show.
The connection is lost for the team viewer.
Sorry. Okay, so the recorded. We enabled recording, and you can now listen to this recording. No application to listen to WAV file on this server. These are WAV files. Okay, on my computer, copy to my folder and open with audio editor. And we see that it is silence, you see? Silence in audio editor.
Yeah, nothing in there.
Nothing. And what? Stop. If we enable the audio again and play it immediately after connection, so no wait, just connect and play. What do we see in audio signal? Let's observe. It appears 3 seconds before answer, and after answer it plays. And we can show recording. This is new recorded file. Copy to my computer. Open. Okay, and we see that it is music WAV file. It's recording. So you can check what happens. What's the audio? Okay. Do you still have time?
This getting pretty late. It's already 3 o'clock here.
Okay, let's continue later then. I'll stop.
I think we covered a lot today, right?
Yeah, 1 hour of video recording. Continue later. I stop then. Okay.